Let's take a look at number 11. Which is true of the series shown below? And let's ignore that. Let's go ahead and look at the answer choices. This is just my strategy real quick. Let's do this. The series diverges. Well, what in the world does that mean? What it means is this. It means several things, but if I was to plot these points as like the first one is pi, the second one's this, the third one is that, the fourth one is that, and I was to continue this pattern, would the graph go like this? Whether it looks exactly like that or not, I don't know, but if it goes away from the x-axis, then it would diverge. So I can do it that way. I actually might do it that way in just a second if the mood hits me. Another way of looking at it is to say it diverges if r is greater than 1. In other words, these numbers are getting bigger every time, and so trying to add them is not going to bring you to a small, nice, beautiful number that you can just put in a box and say, this is the sum. Okay? I'm going to go with an unconventional method. The mood just hit me, so let's do it. I'm just going off on a whim here, and I feel like doing it. I want to pull in something different that we've learned, so let's go for it. Just watch if you need to. Press Stat, press Enter on Edit. We're going to clear out our lists. There we go. That is the first one, the second one, the third one, and the fourth one. Oh, shoot. Let's do the fifth one, too. It looks like fun. L2 is going to be pi. I lied. L1 is going to be pi. Or list 2 is going to start with item 1 as pi. My word, that was confusing. Okay, item 2 is 3 pi over 4, 9 pi over 16, 27 pi over 64. Okay, we still have one more to deal with here because the mood hit me. So let's see, what are we doing to get from one number to the next? I'm going to draw the next one. First of all, I know it has a pi in it. Let's just be realistic. It better have a pi in it because I'm hungry. Let's see, what are we doing to our numerator every time? 3 and then 9 and then 27. Oh, we must be tripling it. What are we doing to our denominator every time? 4, 16, 64. Oh, we're multiplying it by 4 every time. That would be 256. So there we go. I just felt like throwing that one in there just so we can see it. 81 pi over 256. There we go. We're going to plot this. And when we plot this, we'll see if it does this or not. And when we see that, we'll know if it diverges. We're about to decide if we can rule out choice A as an answer. So here goes. Turn our plot on. Let's go to zoom, and you know it's number 9, but in case you don't and you have to hunt for it, you can go down and you see that it's zoom stat. There it is. Now I have a random function graph here. I'm going to clear that out. Here we go. Let's go back to graph. Okay, if my x-axis is down here, then it's coming down towards it. So sure enough, it is converging. It is not diverging. A is not an option. Okay, let me say it one more time a different way. If r is greater than 1, and just for the sake of mathematical argument, or if r is less than -1, which is not the case and it's very rare, but if r is greater than 1, if our common ratio is greater than 1, then it is going to diverge, which really means that our common ratio is probably less than 1. So here's the deal. Let's figure out what our common ratio is, and there's an easy way to find it. I'm going to write down what's happening because there's so much going on with this problem. I'm just going to kind of make it a little more methodical. Let's find the common ratio. That's going to help us more than anything else. Now that we know that it's not diverging, we know it converges, but now clearly we can't just randomly pick. We're going to have to figure out, well, you could randomly pick. Don't do that. But now what we're going to do is decide what it converges to. But in order to do that, we're going to need the common ratio. And the best way to find the common ratio is a wonderful way of doing it. Sometimes when it's not obvious, this is what I like to do. Second term divided by first term. So let's do it. 3/4 pi over pi. Mr. Reader, that's confusing. Quit your whining. It's not. Pi cancels. What are you left with? 3/4. 3/4. So the common ratio is 3/4. That's going to come in really handy. Well, how are we going to use it, Mr. Reader? Well, let me tell you. This is a series. A series means we are adding things together. All right, stay with me on this because I'm going somewhere. Again, we have to find what it converges to. We are going to find the infinite sum. We're going to add them all together. That's going to take forever. Why don't we use the formula? We just used this formula a couple problems ago. All right, looking for the sum. We know the first term. We now know R. Now you're probably tempted to type that in your calculator. I'm going to avoid that temptation. It'll give you an answer. That answer will be a decimal. So if you were to grab your calculator and say, hey, let's start typing, and you get the thing right, I'm not going to hit enter because it's going to give me a decimal and I have to match it up anyway. So let's just go the good old-fashioned way. Here goes. Pi over 1 minus 3/4, that's 1/4. Pi over 1/4, pi divided by 1/4, let's be realistic, that's really pi times, flip it over, 4 over 1, that is 4 pi. We just found it. The answer is D. Okay, you good? If you're not good, may I give you a different method? It's not always going to work, and it's not the best thing to do. But if you're totally stumped and this looks foreign to you, here's what you do. If you are fortunate enough to be taking a multiple choice test, now I'm not trying to teach you how to pass a test. I'm trying to teach you math. But you can do this. Now you might have to figure out a couple more terms. Actually, I'm going to type the next one. 81 times 3 is 243 pi divided by, and then 256 times 4 is, give me a minute, 1,024. And when you do that, you start getting numbers like this, and you have to decide, and now we're not done by any means. We're not done until we get to an infinite number of them, which clearly couldn't happen. But we're going to see what it converges to. So we could keep on going and keep on adding these things, but basically by doing what we just did, we have eliminated the things that it couldn't be. For example, 3 pi over 2 is too small. So that would rule that one out. So B would be out if you're going to use this method. And 4 pi over 3 is also too small. So that would rule this one out. Now, like I said, this won't always work. Sometimes you'll need to know this formula and know how to go through it.